Now, a different approach to feature matching models is the idea, rather than using three-dimensional features as being the features that you decompose an object into in order to recognize it, it rather uses two-dimensional features, two-dimensional simple features like edges, lines, corners, that sort of thing. And these are typically instantiated in so-called connectionist models. Let me give you an example, which is often referred to as the Pandemonium model. So the idea is that you would have a so-called image daemon, and this is really where the incoming information um, enters the system. So in the case of vision, this would be your retina. So that's where an object would appear sort of on the retina. And then the system, the job of the system is to decompose that, first decompose it into these simple two-dimensional features, and then sort of from that infer what the object that you're looking at is. So you would then have the input or image daemon would then talk to and report information, or rather trigger activation in so-called feature daemons. And these might be a sample of the features that you use to decompose the incoming sensation into. And these are, sort of lines or edges or corners, those sort of features, or two-dimensional features. And then these would then talk to the next layer, which are cognitive daemons. And so these are actually, this is where the pattern is stored in your mind. So these up here, for example, are the letters or the patterns that match letters stored in your mind. And then above that, there would be a so-called decision daemon. So that's the daemon that is responsible for saying, okay, this is what I'm seeing. Let me show you how it works, which will sort of help understanding it. Let's say that all of a sudden this pattern were to enter the system. So this pattern would hit your retina. In the Pandemonium model, what will happen is that this pattern will activate all the features that it contains. So for example, the A comes in, it would activate the slightly oblique line, and then, small horizontal line, and then the other oblique line. It would probably trigger activity in the little acute pointy angle. So this is how we've decomposed, right? All these features noticed that they were present in the input. Now that we've decomposed the input into its features, these features will then elicit activation into any cognitive daemon or any representation that has these features. So for example, this oblique line will trigger activation in the A, since it's the only letter that has this particular oblique line. The horizontal line will trigger activity in the A, but also in the B, also in the E, also in the F, and also in the H. So in a sense, you can think of this a bit like a competition. All these cognitive daemons are getting activated by the features that are detected in the image. And in the end, the one that is the most activated by the sum of all the features detected is the winner. So after the horizontal line, we get the other slanted line. And of course, this would only activate the A, which now has been activated 3 times. And finally, there's the pointy angle. And this one too only applies to the A. So the A now gets very active. So finally, once we factored in all the features that were detected in the input image, A is the most active cognitive daemon. It's the most active representation. So it must be that what we're seeing is an A. And that's the job of the decision daemon, to sort of tally out the amount of activation of each of these input daemons. Now, of course, if you actually turn all of the features into particularly corner detection, then it becomes easier to also have the system be robust to rotations. It doesn't quite matter in what viewpoint you see it, as long as there is something that has, for example, this kind of intersection or this kind of intersection, you might recognize it as an H. So this type of model, on the one hand, is akin to the recognition by components or GEONS theory, because it tries to decompose the incoming stimulus into its essential features, but it uses very different features. It uses two-dimensional features instead of three-dimensional features.